Welcome to 7.6 Rational Exponents. We're going to start with some basic rules. These rules will go both ways. So we might be given something that looks like this, a base raised to a fractional exponent. And here's what we're going to do with it. We're going to keep the base b. We're going to take our top exponent and we're going to put it inside. The lower exponent, c, will be our index. I always relate this back to the square root function. If I had the square root of c, I would rewrite this as c to the 1/2. So if you're ever confused, always take it back to the square root function. And just remember that that square root is represented by the 1/2 power. The same way on the bottom, we have b to the 1/c. b is our base. It's raised to the first power, so the 1 goes here, and on the outside, it has an index of c, whatever that c may be. So here's the two types of problems you're going to have. They are either going to give you this portion with a fractional exponent, and you'll be asked to write the equivalent, or they're going to give you the root, and they're going to ask you to write it in exponential form. The first type that we're going to see are written as roots, and we're going to take them and write them as exponential powers. So the first one we're going to do is x squared under the fifth root. When we keep this base of x, it's 2 and 5, so it's going to be 2/5. Notice the power that is with the base always goes on the top, and the index, the 5, always goes on the bottom. In this case, we would have negative 27 under the third root. Negative 27 is raised to the first power, so we would say this is negative 27 to the 1/3. The next example, if it's a square root, it has this 2 that is understood outside, so we have 6 to the 3/2. Notice this exponent that is a fraction can be an improper fraction. That is totally okay. It can be a regular fraction, 2/5, or it can be 3/2. The next one, the entire x times y is raised to the 9th, so we would say this is x times y to the 9/7. And again, we're okay with having an improper fraction. I want you to try the next 4 on your own. So go ahead and hit pause, complete the problems, and then we'll go through them. The first thing I like to do whenever I don't have an exponent written is I like to put a 1. That tells me that this is going to be the top of the fraction. So this is going to be m to the 1/6. This one kind of makes sense, and it's a really relatable problem because you notice you cannot simplify the 6th root of m, nor can you simplify the 1/6. So it makes sense that this is written in this way. And I think that you'll see this more on the next example as well. We have x to the 8th. That means that we're going to rewrite this as x to the 8/2. Then we're going to take that and we're going to simplify this fraction. So if we can simplify it, we definitely will. So this is the same as x to the 4th. Because 8 divided by 2 is 4. We can do it with variables. We can do it with numbers as well. So here 4 would be raised to the first power. So we would rewrite this as 4 to the 1/5. And our final one, t to the 8th, all under a 7th root, would be t to the 8/7. So again, we always take the power and it goes on top. The index, which is on the outside, goes on the bottom of the fraction, and then we reduce it if we can. The next set of examples are going to give us rational exponents, and we're going to write them as roots. So here we have 5 to the 1/2. We're going to rewrite this and we're going to say it's 5 to the first, all under a square root. Remember, this 2 is here even though it's not written. So in most cases, we delete it and we don't write it there. And also we delete the 1. So this is what our final answer would look like. On the next one, we would have 25. It's 25 squared, all under a cubic root. The top number tells us what goes under here, and our bottom number tells us what the index is. And again, we always take this back to the square root. Here we have a negative exponent. So that means we have to take this and make it switch it to the bottom and make it a positive exponent. So just using our same exponent rules, doesn't matter, it's a fraction. And then I'm simply going to take this and make this c to the fourth under a cubic root. So I've done 2 steps. All I've done is moved it because it was a negative exponent, and then I wrote it as a root. The next example, d to the 5/8 would be d to the 5th with an 8 as the root. Notice 5/8 cannot be simplified, nor can a 5 as a power under an 8th root. Neither one can be simplified. So we should be able to double check these and be pretty confident in our answers. I want you to again hit pause, and I want you to complete the next 4 problems on your own. Hit play when you want to resume. All right, we're going to go through the next couple. So we have 4 to the negative 1/2. It's the same as 1 over 4 to the positive 1/2. Positive 1/2 means that we're putting 4 raised to the first power, and it's under a square root. So now we have 1 over 2 as our final answer. The next one, m to the third over 2. Notice this is an improper fraction. It's m to the third under a square root. I'm not going to write the 2 on this one. And that is your solution. 25 to the 6th, all under the 7th root, because the 7 tells us what the root is going to be. And the final example is a negative power, so we're going to switch it to the bottom, make it a positive exponent, and then we're going to take this and we're going to rewrite it as 1 over, and it's going to be 3 to the 5th under a square root, because this 2 tells us it's a square root.